Hi guys, in this video we're going to talk about electric fields. I wrote that over here in the topic. Make sure you put your name, class period, and date over here. Our essential question that we're going to be asking today is, what do electric fields look like and how do I find them? Okay, so electric field. I'm going to make some comparisons to gravitational field here. Okay, so an electric field kind of gives you an impression of a visual representation of what the electric force looks like. So let's go ahead and write the definition. Electric field is the force, the electric force, per test charge. And it's important to note that what this is a positive test charge. And so what it looks like when we draw a picture of it is we put our whatever charge we have. So this is our charge in question that we're looking for an electric field around. And what we do is we pretend to have a test charge that's positive. This is going to pretend to be my test charge. And then I think about, what is this test charge going to do? Well, if I put a positive test charge right here, it's going to be pushed away by this positive charge here. So right there, I would draw an arrow going away. Now, if I get it closer, it's going to be pushed a little bit harder. So here, I would draw a longer arrow. Nice. And then if I were to put it over here, it would get pushed over this way. And if I were to put it over here, it would get pushed down. So what I'm doing in making my electric field is I'm thinking about which way a positive charge is going to get pushed. So the closer it is, the stronger that force. And so these lines would be longer, and way out over here it would be even shorter because it's not as strong over there. So this gives me an impression about what the electric field looks like. Those arrows represent the electric field. So it's stronger in the middle and it gets weaker as you move outward. That is what an electric field looks like. So how do you calculate an electric field? Well, first off, it's a vector quantity, so we put the little arrow on top. And you find it by taking the force and dividing by that test charge, which is usually positive. So to find the electric force, what you would do is you would take that K, Q1, Q2 over the distance squared, and we're dividing that by the test charge. Now the test charge is going to be one of these charges. It doesn't matter which one you pick. I'll pick this one, so I'm going to write, instead of 2, test. So that means that these Q's are going to cancel out. So to find my electric field, I just need to know what this charge is and how far away I'm looking. So this would tell me the electric field at a point some far away from the charge Q. Now it looks a lot like the force, it's just missing that other charge, and that's pretty much it. Now a gravitational field looks the same way. Instead of a capital E, it's something else. But actually I think they use a big G most of the time. But the gravitational field has instead a big G right here for that gravitational constant, and then the mass of whatever you're looking for, and then this distance squared. The interesting thing is that's also how you find the acceleration due to gravity. So a good interesting way to think about this is it's the acceleration due to electric forces. So so there's our electric field. So that's one way to calculate it. This is another way to calculate. Those are both electric fields. So that's what an electric field looks like and what it calculates. Let's think about this really fast. I'm going to draw a line here, like these are separated, and we're pretending that's not there. Since this is a negative charge, my positive charge is going to get pulled toward it. So the difference between an electric field around a positive charge and an electric field around a negative charge is the direction of the arrows. The closer they are, the stronger they are, so that arrow just kind of went right through there, sorry about that. And the farther away, the weaker they are, but the arrows go inward toward a negative charge and outward toward a positive charge. In the activity you played with the simulator fields, electric fields and charges and fields, I think is what it's called. You hopefully played with two charges to see what the electric field looks like when you have either two of the same charge or two of the opposite charge. If you did not do that for whatever reason, you need to make sure and go back and do that right now. All right, so thanks for watching. Make sure you fill in some questions and write a summary here. That's always very useful to get you to understand it a little bit better.